Hello engineers, welcome back. In the last few videos we studied about trees, binary trees and binary search trees. We got all the theory and the coding experience. In this video, let's solve a lead code question based on binary trees. Okay, I hope you're ready. Let's get started. So this is the question we're going to solve today. It's called invert binary tree. Okay, let's try to understand the question and we'll see how to approach this, right? So given the root of a binary tree, invert the tree and return its root, right? So we can visualize this using these examples. So this is the tree, the root is 4, and then we have 2 7, and then we have 1 3 6 9, and the invert of this tree is 4 7 2 9 6 3 1. So as you can see, if we look at it from level to level, on the first level the root remains the same. On the second level, the left node is swapped with the right node, and on the third level, 1 and 3 are swapped and moved to the right side, and 6 and 9 are swapped and moved to the left side, right? So there is swapping with the children and there is swapping at the parent level as well, right? And let's see this example. This has only 2 levels. So we have root 2 and then we have 1 and 3 in the next level. So now here we have 2 followed by 3 and 1. So the children left and right are swapped, okay? So that is what we need to do here. We need to swap the given tree to this format, and then we will need to return the new root, right? Let's see how we can approach this. So let's take this example, 4 2 7 1 3 6 9. Okay, so this is the tree we have. So we need to remember that in binary trees or in any trees for that matter, we are not actually connecting the values. What are we connecting? We are connecting one pointer to the other, right? So trees are pointer connections. Okay, I'll just leave it here because this is a good reminder, right? So trees are pointer connections. So when we are trying to do a problem such as invert a tree, we are not actually trying to change the values. What we need to do is look at these guys. Look at these ones. These are the connections, right? This is what we need to change. This is what we need to swap, right? So we don't need to change the values. We don't need to go left of 4 and right of 4 and then do some swapping, right? But we can swap the connections. Once we swap the connections, the children are also taken care of, right? Because this is connected to this is connected to this, right? So let's see how we can approach this. So this is a typical recursion problem. Let's see how we can do this. In any tree question, right? What are we doing? We can either go to the tree and traverse it one level at a time, or we can go deep into the tree and come back up. So this is called depth first traversal and this is called breadth first traversal. So we have seen all this in theory, right? So to approach this is what we need to do. We will use the depth first search, right? So we will go down the tree, we will go all the way down, and when we reach the root leaf nodes, we will come back up. Okay, we will come back to 2. Once we are at 2, we will swap the children. Okay, now the tree will become like this, right? So this is how the left side of the tree will look like. So once we are done with this, we will go back up and then we will repeat the same thing on the right side. We will go deep into the right tree and then we will swap the children. Okay, so we come back up and swap the children. So once this level is done, we will repeat the same thing at this level. Now the next step is to swap the parents. So now the parents will get swapped and the children are already swapped, and this is the final output. Let's see, 4 7 2 6 9 3 1. 4 7 2 9 6 3 1. Oh sorry, I didn't swap this here. So these are already swapped, right? Yeah. So this is our answer, right? So this is a simple recursion problem. Let's see how we can code this. So first we will make our helper function where we will do our recursion. So let's call it invert, and we will pass our root to that. Okay, after that, whatever is the updated root, we will simply return it. Now let's build our helper function. It will not return anything. It will take in a tree node, and let's call it node. Okay, so we are starting at the root. So first we go to the left side of the tree. So we use recursion to travel to the left side of the tree. So we go node arrow left. So what will this do? This will keep calling recursion and keep going down the left side, right? And somewhere we need to stop it. So that will be our base case. So if we reach a null pointer, which means we have found the depth of the tree, then we can simply return from here. Okay, that's our base case. This is our recursion case. And then we can do the same thing on the right side, right? So what is this doing? Let's see. Invert node arrow left, right? So we are going left, 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 and then we hit null pointer, we hit the base case, we come back, and then we go right. We go right, 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 we hit the base case, and then we come back up. Now we are here. We are at the node 2. What do we need to do? We just need to swap the children, right? So we can use a simple swapping logic. We can create a temp pointer which is pointing to node arrow left, and then we can replace node arrow left with node arrow right. We are changing the pointers, remember, not the values. And then node arrow right will become temp. So quick recap, this is the base case, this is the recursive case, and this is our operation, right? And that's it. And it will come back here and we will return the root. Let's run and see. It's not node, it is tree node. Right. Okay, our solution is accepted. Let's submit. And we are done. Okay, so that is the solution, and let's see the time complexity. So the time complexity is O of n, because we are practically visiting every node once, right? We're going down the left side, we're going down the right side, and then we are just visiting them and then doing a swap, right? So that's why it is O of n. So that's it. It was an easy question. I hope you found it helpful. Thank you so much for watching, guys. If you have any question, definitely ask me. Don't forget to leave a like. Don't forget to comment. If you have any questions or suggestions, please subscribe to the channel if you haven't done already, and share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.